Okay, it's going to be another chain rule. This is going to be a long one. We're going to start with the chain rule because I have an inside of e to the 2x, natural log of x squared minus 1, and outside of an exponent of 3. So starting on the outside, I multiply by that exponent, change nothing else than times the derivative of the inside. So, derivative outside, plug in plain inside, derivative inside. Chain rule. So the chain rule got me started. So now I'm basically done with that. So now I have to look here, and my derivative of the inside needs product rule for differentiation. So doing that. So doing that product rule now. Big set of parentheses. Plain first. Derivative of the second. Plus plain second. Derivative of the first. Plain first. Derivative second. Plain second, derivative first. Keep whacking away at it. And yeah, these problems are getting long, but what you want to note is that we do them one small step at a time. I didn't start by writing down the answer. I started by figuring out, oh, I had inside and outside, so I'm going to do a chain rule. Then the chain rule says this. Then I looked at the new derivative. It says product rule, so I write down what the product rule says. And then I just keep going. Plain first, so do nothing. Then I get to the logarithm. 1 over the argument, derivative of the argument. I'm up to the plus sign. Plain second. So leave it alone, then derivative of the first. It's been a while, but it's repeats, derivative of the exponent. You need to know all those basic things that describe how to differentiate. Product rule, quotient rule, chain rule, natural exponential, repeats, derivative of the exponent, natural log, 1 of the argument, derivative of the argument. And now simplifying. And there's not going to be much that we can do here to simplify. Then on this first term, all I would do there is just put it all together in one fraction. And on the second one, really nothing you can do with this second term, except put the 2 and the e to the 2x in front because it looks prettier there. And there's my answer. There's not much other good stuff you could do. I'll make this correct on the end. I can make it correct, but there's a good enough answer. Okay, moving on. Last basic problem. Then we'll go on to something slightly different. There are my properties of logarithms again, how I can split up logarithms, put logarithms together, reminding you of my properties of logarithms. So when I look at this problem, there's an easy way and a hard way to do it. Hard way, do not simplify first. But think about it, if you didn't simplify it first, and I just used my words, 1 over the logarithm, or excuse me, 1 over the argument, drew the argument, even the 1 over the argument's bad. 1 over all that stuff, then the derivative of all that stuff, not impossible, but not any fun at all. When you see that the properties of logarithms could help you simplify the original, we are going to simplify first using the properties of logs. So, first of all, I can split up that fraction by subtraction. And I'm going to rewrite the square root of tangent with an exponent. So that was the quotient rule for logs. Then keep simplifying. Now I've got some products. And so there was using product rule for logs. And careful parentheses use that with this minus sign, when I went to use the product rule for logs, parentheses split the whole thing up. And now all those exponents can come down in front, and we can recall here that that's just going to be 2x. Natural logs and e's are inverses. So writing one more time, there's an exponent. Remember, that means it's on the entire sine's 2x. So that 2 can come down in front. So I have natural log of sine of 2x minus 2x. Natural log and e's cancel, so I get 2x. And then minus 1/2 natural log of tangent x. And so using power rule for logs. And there, that is still the original. But it's in a much more calculus-friendly format. For all the logarithms, I can just do 1 over the argument, derive the argument, and from 2x, derivative of 2x is just 2. So now each time, 1 over the argument, derive the argument. So 1 over the argument, derive the argument. The 2, just a coefficient, so it just stays there. 1 over the argument, derivative of the argument. And then we need to remember back to when we learned the chain rule, and we said that when you're doing these trig things and your argument, your angle was just linear, mx plus b or mx, the effect of that slope every time was to multiply by it. So the derivative of sine is cosine, the angle doesn't change, but then the effect of that 2 from the chain rule is to multiply by it. Then the derivative of 2x is 2. The 1/2 just stays. Then 1 over the argument, derivative of the argument. And so all of those, each and every logarithm, 1 over the argument, derivative of the argument. And so a final pretty answer, 1 over x. 2 times 2 is 4. Then notice here, I have a cosine 2x over a sine 2x. Cosine in the numerator, sine in the denominator, cosine 2x over sine 2x for cotangent 2x. Then I have minus 2, and then on the end, I would call that secant squared. And depending on what you want to do, you got some options here. But on the end, I would say that's minus 1/2. 1 over tangent is cotangent. And then I have the secant squared. And there's my derivative. But again, real point to this one, we simplified first. If you hadn't simplified first, you'd still be working on this problem and you'd probably get it wrong. Let's end that video.